This tutorial will show how to model a mat foundation that supports a wall with an overturning moment. The mat is 1.5 meters thick, supported in its entirety by soil springs. The only loads on the model are the self-weight dead load of the mat and the overturning moment on the wall. We will create the model using the mat template. We will use the Euro code and kilonewton meter units. We will set the edge distances to 0.5 meter. And along the X, we will have 4 spans with spacing of 6 meters. Along the Y, we will have the same edge offsets, but only 3 spans with spacing of 5 meters. We will set the column loads to 0, as the only loads are self-weight and the overturning. The mat is 1.5 meters thick, and we will use the default subgrade modulus for the soil springs. The units are kilonewton per meter squared for the soil modulus. Next, we will switch off the dimension lines and horizon. If we go to a corner, we can verify that the edge has been offset 0.5 meter. Next, go to the top right corner and right-click, and on the Point Object Information form, change the location of the point to have an x-coordinate of 22.5. Right-click on the bottom right corner and change the x location of this point to 22.5 as well. Right-click anywhere off the model and select the Modify Grids command. Change the grid E ordinate to 22. Next, we will review the material properties. We will use the default C30 concrete. Checking the mat property, we see the correct thickness is set. The element formulation used in SAFE always includes shear deformation, which is especially important with thick mats. Next, we will define a wall property. We will set the wall thickness to 20 centimeters. Now we can draw the wall. The wall will extend above the mat. And occurs along grid line 3 between C and D. Leaving the draw mode, we will review our soil property. We will add a second soil property called Soil Soft. with a subgrade modulus of 12,000. We are going to apply these two soil properties in two different areas. Start by selecting the slab object and assigning a soil support of none. This removes the previous assignment generated from the template. Next, draw a rectangular area object in the top right corner using a property of none. We will use this object to assign our soft soil springs. Assignments may also be done using the Model Explorer. Holding down the left mouse button, we can drag a property onto an object. Draw another area object over the remainder of the slab, again with property none. We will use this area to assign the stiffer soil springs. This time, we will assign the soil using the Assign menu. Now we will switch to a 3D view. We are also going to change the color scheme. Select the top corner points of the wall and remove the restraints. Next, we will define the load patterns. We can delete the live pattern as we have only self-weight, and add an earthquake pattern. For the load cases, we will add two uplift cases. Both will be nonlinear to allow uplift, and the first will have 0.9 times the dead load plus 1 times the earthquake load. And the second case will be identical, except that the earthquake load will be applied in the minus direction. Now we will apply a moment couple for the overturning load. Select the bottom corner of the wall and apply an earthquake load in the gravity direction of 2,000 kilonewtons. Zoom in and repeat this at the other corner. But with a 2,000 kilonewton load in the up direction. We are now ready to run the analysis and design. Once the analysis is complete, the deformed shape for the dead load case is displayed. However, it is the uplift load cases that we are interested in, so we will revise the display. First, uplift 1, and now the deformed shape for the earthquake in the other direction. Next, we will switch to a display of the soil bearing pressures. Note how the soil bearing pressures do not go positive, indicating that there is no tension in the soil springs. This concludes this tutorial.